Hello everyone, I welcome all of you to this particular video. In this video, I will talk on Word2Vector. Here in this video, I will not go through in details Word2Vector that is done after learning deep learning. So we will study Word2Vector in detail in the deep learning section. For now, we will just have the overview of the Word2Vector. So see you there on whiteboard. Let's get started. So let's jump to the topic Word2Vector. So here we'll study Word2Vector. Before starting Word2Vector, let's have a recap of the last video. In the last video, we have been learned about the TF-IDF, where we have seen that TF-IDF, uh, yes, it gives us a very good way to convert a raw text into the numeric form that an AI model needs, but still it lacks something which is called finding the semantic meanings of the language. So it fails to find the meanings. It can't say that keen and queen both represents kind of similar word, where both represents a royal family with their gender difference. It TF-IDF or any other techniques that we have been studied is will not be good in learning those. So here comes to Word2Vector. Word2Vector. Let's say we have what does it do? So basically here we have the dimension. So let's say W1 represented in the D dimension, and this will be our V1. So let's say we have W2 this also with D dimension, and here we will have V2. So what does it do? Let's say W1 is the word say tasty, and W2 is the word say delicious, and let's say we have third word W3. Let's call it cricket. Cricket. It is also in the dimension, and here we will have V3. Since tasty and delicious, if you look at these two words, basically these two tasty or delicious, these two words are similar. Both means something related to taste. So what Word2Vec tries to do, what it will do when you will train the Word2Vector and comes to the conclusive V1 of the conclusive vectors, then what will it preserve that? It will say that tasty, or you can say, let's say W1 is very similar to W2, and while W1 will be very less similar, will not be as much similar as let's say W1 with the W3. It will not be as much similar as similar W1 and W2. So this is what Word2Vector preserves. How exactly Word2Vectors get done, we'll not study that here. That will be studied after learning the uh, deep learning. So we will sure study when we'll learn for sure about Word2Vector. We'll study in detail when we will learn the deep learning. So for now, just let's understand the from the higher perspective. So this is the core ones. Actually, videos get corrupted over here, so I am re-recording from here. I'm really sorry for this. So basically, I was talking about the semantic meanings. I was telling you that that Word2Vector also preserves the semantic meanings between the words. Let's understand it with an example. Let's say we are having queen, king, W1, and its vector represented with vector 1, then queen, Word2, V2, man, Word3, V3, woman, W4, V4. So basically, these uh, I was saying you that word to vector also preserve the semantic meanings. I mean is that if you will do v1 minus v2, it will be very similar to v3 minus v4. How? Because if we'll do using any kind of distance difference, whether it's equilibrium or something else, if we'll do so, then king minus queen all left with the gender difference, because we have cut out the difference of the royal status of between king and queen, and similarly if we'll cut out the man woman difference, then all we are left with the gender difference. So both gender difference will be very similar to between man and woman and king and queen, since royal difference cut it out between those. So that's why even after performing any kind of operations, any kind of distance operation, so it also preserves the semantic meanings between those. And this is and this concept basically makes Word2Vector so much powerful that it can also be used for some other purpose like this as well. What I wanted to tell you, actually, I forget what was I saying. So, actually, I wanted to tell you that this one, uh, let's say we have V1, V2, and here we have V3, V4, V4, V5, here we have, let's say, V6. So basically, how does Word2Vector how finds out the semantic meanings? It sees the neighborhood. It works on the principle of neighborhood. Since V3 and V6 having same kind of neighborhood. If you see the neighborhood, this one is the neighborhood of V3, and V6 also have the same neighborhood. So what does it do? Since V3 and V6 having the same kind of neighborhood, then V3 will be very similar to V6. This is the core principle that we will learn. So, and on this very core principles, we come up with the Word2Vector representation of the raw text. How exactly we do, we will see in the deep learning section. For now, just have the higher understanding of it. So that's it for this video, and see you all in the next video. If this video find you informative, then please share it with your friends, colleagues, so that they can also get benefits from it. And it's going to be a very long journey. I just started it. There are a lot to study, and we will together study it in detail. So see you in the next video. Till then, bye bye. Have a great day.